Everyone. I want to share this picture of last year's Earth tournament from NASA. This is me, and next one is like me at the beginning of the project. Earth observation satellites provide us information about weather events, land, sea, or natural disasters, migrations, Earth energy consumptions. And of course, their number is not a few. According to Committee on Earth Observation Satellites, there are 500 Earth observation satellites around the Earth. From the European Space Agency, in terms of Sentinel family, a total of 50 million products had been downloaded by users since the start of the data access operations, with a total data volume 41 petabytes. Sentinel-2 carries a high-resolution multispectral imager with 13 spectral bands for new perspectives of our land and vegetation. These bands can be thought of as certain intertwined wavelengths obtained from the sensor. The resolutions provided by the band we have chosen are different. The resolution of an image refers to the potential detail provided by the imagery. Actually, in remote sensing, we refer to three types of resolution: spatial, spectral, and temporal. Spatial resolution refers to the size of the smallest feature that can be detected by satellite sensor or displayed in a satellite image. Spectral resolution refers to the ability of satellite sensor to measure specific wavelengths of electromagnetic spectrum. Temporal resolution refers to the time between images. We determined our work area with spatial resolution and spectral bands selection that we applied to this metadata. Even this process can take time on our normal computers. We can do these operations via command shell or the graph processing tool with Python that we can run jointly on Windows or Unix systems. So we can do this process using GPT and Python with the HPC provided by the Irish Centre for the High-End Computing (ICHEC) at New Galway, without going into snap software of our computers. Although we work in specific region when dealing with GIS data, more than one layer is used in studies. If there is a layer, spatial or non-spatial machine learning can be applied to it. But in analysis of GIS data for the multiple layers used in this process in our normal computer, it lasts too long for a very small region. So with XML file of that metadata, we can do these steps on the high performance computing terminal. With this implementation, the processing of the metadata is getting significantly faster. We can obtain the subgroup we created from this by entering the specific algorithmic calculation. Necessary corrections can be made for the analysis of the image. In our case, clear cloudless data was required for the detection of algae, so we applied also atmospheric correction from the beginning. There are some of the pictures that I selected to show you as handling the metadata from the beginning. Since the world is getting bigger, we need to implement more Earth observation data with HPC, like tracking weather pollution, analyzing COVID effects, or any disease, forecasting of hurricane or avalanche. In the last 10 years, artificial intelligence, and in particular deep learning, has increased the potential for remote sensing in an increasing number of applications. Who knows what they bring in the future for that area? Like we did for several decades, as many forecasting and analysis, the new work areas will come up with the new HPC implementations. And I want special thank you for being my project mentor, Tusita Karki. Everyone, I want to share this picture of last year's Earth tournament from NASA. This is me, and next one is like me at the beginning of the project. Earth observation satellites provide us information about weather events, land,